In the previous class, we have seen that in the second case, first we have taken mu1 equal to mu2. Second case, we have taken that mu1 is greater than or equal to mu2 as a null hypothesis. Then mu1 lesser than mu2. That is, average life of CFC technology bulbs is greater than the average life of the original technology. In this case, it is the left tail. We are talking about the left side. So left-tailed test. Therefore, the corresponding test is left-tailed test. Will be seeing about that. Now, the important thing we are going to learn about the type 1 and type 2 errors. Whenever we frame the hypothesis and we are going to test the hypothesis. For testing the hypothesis, we are supposed to take the sample. Suppose the way sample is selected is not correct, then whatever we infer from the sample, the conclusion may not be correct. So, a faulty sample mislead the inference or conclusion relating to the null hypothesis. If you take the faulty sample, then the conclusion using that faulty sample, whatever inference we are taking will be not correct. So the conclusion may not be correct. It's a faulty conclusion. For example, an engineer infers that a packet of screws is substandard when actually it is not. He is telling that it is substandard. Actually, it may not be a substandard one. So, but he concludes because the sample he has taken is not taken statistically. It is an error due to the poor or inappropriate faulty sample. He committed the error because of the sample he selected is faulty. So, similarly, a packet of screws may infer good. He is telling it is good when actually it is substandard. But true scenario is it is substandard. But because of the sample, faulty sample, he is concluding that it is of good, but it is substandard. So we can omit two kinds of errors while testing the hypothesis, which is summarized. So we have to take care that we should not commit such errors. So this is known as the type 1 and type 2 errors. This is about the decision table. Reject H naught. Okay, we are going to reject H naught. Actually, H naught is true. Okay, H naught is true and we are going to reject it. Instead of not rejecting it, we are going to reject it. So it is an error committed. This is known as a type 1 error. When the decision taken is reject H naught, actually H1 is true. Okay, so whatever decision we have taken is the correct decision. Next is do not reject H naught. We are not going to reject H naught. Actually, H naught is true. So such decision is known as the correct decision. Now do not reject H naught, but H1 is true. Where we have committed one error, that is known as the type 2 error. Type 1 is known as the alpha error. Type 2 is known as the beta error. So what the true case is, we are taking some mistake, means we have committed the mistake. H naught is true. Okay, actually it is true, but we have rejected the H naught. Then we committed error, that is type 1 error. Similarly, do not reject H naught. We are not supposed to reject the H naught. Actually, H1 is true. What is the decision we have taken? The decision we have taken is do not reject H naught. But actually H1 is true. So we have committed error, that is known as the type 2 error. So let us take a situation. We will see one example to explain type 2 error. Let us take a situation where a patient suffering from high fever reaches to a doctor. That person is having high fever and he is going to the doctor. And suppose the doctor formulates the null hypothesis and an alternative hypothesis. So naturally the doctor will be framing the null and alternative hypothesis. What is H naught? The patient is a malaria patient. He is just looking at his symptoms. He frames the hypothesis that the patient is a malaria patient. Alternative hypothesis is nothing but the patient is not a malaria patient. So this patient may be suffering from malaria or may not be suffering from malaria. So the doctor is doing the initial diagnosis. So from the initial diagnosis, he frames the hypothesis that the patient is a malaria patient. Well, then when you frame the null hypothesis, actually you will be framing the alternative also. The patient is not a malaria patient. What are the cases? So in this case, what and all can happen? The first one is case 1. So if I talk about the case 1, suppose that the hypothesis H naught is really true. What is H naught? The patient is a malaria patient. That is, the patient actually a malaria patient. Okay, and the doctor is doing the observation, pathological and clinical examination. So observation is done. How the observation is done? Pathologically. Take the blood sample and using the blood sample, clinically testing it. So the doctor rejects H naught. He is rejecting H naught means the patient is a malaria patient is rejected, right? That is, he declares him or her non-malaria patient. Although the patient is malaria, that after doing the pathological test, the doctor declares that he is not having any malaria. So it is not a correct decision. Okay, doctor has committed an error. Okay, doctor has committed some error, right? The decision, taking the decision. This is known as the type 1 error, right? So what is type 1 error? We'll go back to we are going to reject H naught. Actually, H naught is true. Actually, the patient is malaria patient and the doctor says that he don't have any malaria. So he has committed type 1 error. Now we go to the type 2 error. Suppose that the hypothesis H naught is actually false. What is H naught? The patient is a malaria patient. The patient is a malaria patient. Is false means the patient is not a malaria patient. So the patient is not suffering from any malaria. That is a true scenario, right? H naught is actually false. Then the patient actually a non-malaria patient, and after observations, therefore doctor is doing the observation, he is doing pathological test, clinical test, all he is doing, the doctor rejects H naught. He is rejecting that the patient is not a malaria patient. That is, doctor declares that a non-malaria patient, okay, he's a non-malaria patient. Doctor says he's not having any malaria. So the decision taken by doctor is correct decision. Now we go to the case 3. There are case 1, case 2 we completed. We go to the case 3. Suppose that the hypothesis H naught is really true. That is, the patient is suffering from malaria. That is, patient is actually a malaria patient. After observation, he is doing clinical test and also pathological test. The doctor does not reject H naught. Okay, does not reject. Means the patient is a malaria patient and he is not rejecting it. Okay, that he concludes the patient is not a malaria. What is the H naught? H naught is the patient is actually a malaria patient, and doctor is not rejecting it. Means do not reject means he concludes that the patient is a malaria patient. So doctor has taken the correct decision. Now you go to the case 4. Suppose that H naught is actually false. What is our H naught? The patient is a malaria patient. It is false. Opposite of that will be actually the patient is not having any malaria. Okay, now the doctor is doing that. Doctor is doing the observation. He is doing all pathological tests, and the doctor does not reject H naught. The doctor is not rejecting the H naught. Okay, the rejecting H naught is what? If you reject H naught, that means the patient is a malaria patient. If you do not reject means that you accept that your patient is a malaria patient. But here the doctor do not reject it. Means the patient is actually a malaria patient. That is what doctor says. But actually what is the true scenario? The actual scenario is H naught is false. Means the patient is not a malaria patient. But doctor concludes that he is a malaria patient because he is rejecting the H naught. So he declares that that patient is a malaria patient. So doctor has taken the wrong decision. So it is not a correct decision and error is committed. That error is known as a type 2 error. So type 1 and type 2 error. We'll see some more example. The decision relating to rejection of null hypothesis. So we are going to reject the null hypothesis H naught when it is true. Actually H naught is true. But what you are going to reject it. So this type of error is known as the type 1 error. What is the type 1 error? When rejection of the null hypothesis, we reject the null hypothesis. Null hypothesis is not correct, so we reject it. So doing all the statistical tests, we reject the H naught. But actually the true scenario is either way, right? Actually, what is the true scenario? H naught is true. But what we conclude, H naught is not true. So this type of error is known as the type 1 error. The probability of committing the type 1 error is known as the size of the test. What is the probability that type 1 error can be committed? That is known as the size of the test, and it is noted by alpha. This alpha is nothing but P of probability of rejection of H naught when H naught is true. That is probability of reject H naught when H naught is true. We can write a probability like this. We are going to reject H naught, but actually the H naught is true. So this is known as the alpha error, or known as the size of the test. We reject the null hypothesis if random sample test statistics fall in rejection region. That is alpha equal to a probability of x belongs to omega, that is the rejection region, such that H naught. So x1, x2, and so on to xn is the random sample, and omega is the rejection region. That is 1 minus alpha will be 1 minus P of rejection H naught. Actually H naught is true. So do not reject H naught when H naught is true. It is a correct decision. The opposite of this is a correct decision. So 1 minus alpha, the probability of correct decision, and it correlates to the 100 into 1 minus alpha percentage. That is confidence interval used in estimation. Means what are the types, means how we reject H naught and how we do not reject H naught. That refers to this type 1 error is nothing but our size of the test, and it is known as the alpha error. The probability, because we are taking no 1 minus alpha, opposite of that will be do not reject H naught when H naught is true. It's the opposite of this. The previous one whatever we have taken is the opposite of that. This is P is correct decision. This is known as level of significance. Alpha is known as the level of significance. The probability of type 1 error is known as the level of significance. What is the probability of committing type 1 error? Is known as the level of significance of the test. For example, if you are supposed to take 0.95% confidence level, but you have taken 99% confidence level. As you increase the confidence level, means chance of committing error will be more. It is also called the size of the test or size of critical region, denoted by alpha. Generally, it is prefixed 5% or 1%. Most of the cases, especially in education, we fix as 5% or 1%. So you have seen that the critical value, rejection region is one-sided error. Critical region is one side. Here in this another figure, that is also rejection region, that is also single tail test. This is right side single tail test, it is left side single tail test. And two tail, both the sides. Maybe left or right, both the sides are included. This is known as the two-tailed test. Now we go to the type 2 error. Type 2 error is what? The decision relating to non-rejection of null hypothesis. We are not rejecting the null hypothesis, but actually it is false. H1 is true. Opposite of that is H1 is true. Either you take the H0 or H1. Both, don't take both at a time. You will get confusion, right? The decision relating to non-rejection of null hypothesis. We are not rejecting the null hypothesis, but actually H0 is false. Although it is false, we are not rejecting it. What is the true scenario? H0 is false. That is the true scenario. But what we did? Non-rejection. We are not rejecting it. We should reject it. Okay, it is false. No, we should reject it. But the decision, we did mistake in taking the decision. What we did? We do not reject it. Okay, not rejecting it. Therefore, we committed the mistake. The probability of committing, this is known as a type 2 error or beta error. Okay, the probability of committing this type of error, that is known as a beta error, beta is nothing but probability of do not reject H0 when H0 is false. That is, do not reject H0 when opposite of that is H1 is true. So do not reject H0 when H1 is true, right? So we can write the probability beta will be x belongs to omega in the critical region H0. So non-rejection region. So 1 minus beta is 1 minus do not reject H0 and H0 is true. Opposite of that, okay, complement of that is reject H0 when H1 is true. This is correct decision.